Much better, right? Now you can all understand me. So I understand this has been a tough day for you. Has it? Why is it a tough day if you only play games, right? It's like, that's good, isn't it? So I have like 45 minutes, and Simona said, could you please energize the people? I'll try to. So if you're tired, please pay attention. This will go really, really fast. This is normally a talk I can do in 60 minutes, but I can also do it in 90 minutes or in a half day. And now I have 45, right? So my time box, which is a very good technique, is limited. And as soon as I switch my first slide, my timer starts running. I'll turn my laptop a little bit. Right, so here we go. So I'm going to talk actually about how software development is changing. And it is changing at a very, very high pace. And I'll try to explain to you how fast it is changing and what will happen to software development and to our industry in the coming years, at least if I get a say at it. Right, so this is me. I'm Sander. I'm from the Netherlands. I have 3 kids, as Dan already explained it. I'm an independent dad. That's because I separated from their mother a couple of years ago. I'm basically a programmer. I've been writing code for 35 years already, since I was 15. And I spent most of the day, since I don't understand Romanian, I couldn't enjoy the game, so I sat in the back of the room programming. And I checked in a lot of code today, so I hope nothing breaks down in my team. And I do talks at conferences, and I write stuff. I've written a couple of books and stuff. And my current assignment as a freelance, because I'm also a freelance, I'm the CTO of a company that writes software for the insurance market. And I'm trying to sort of change this company and to change the way they use technology into, let's say, the modern era. Their current product that they have out there is built in COBOL. Yes, and they still have 15 COBOL developers on board. They come in with their sticks every morning, and they go out every night with their sticks. Well, I'm not kidding. That's actually true, by the way. So, this is my Twitter tag. It's somewhere in there. If you feel the need to tweet about this talk, please do. So I've written a couple of books. None of them might interest you because they're either in Dutch, which doesn't help. I wrote a book about modeling in 2003, big book. I wrote a thinner book about Agile. I wrote another book about Agile a while ago, but I couldn't find the cover of it. That has been translated to German and to English as well. Of course, you understand that the German version is twice as thick as the Dutch version because they only have really, really long words. I was in Germany yesterday, and I tried to read the signs, and there were these big words on it. The English version is thicker as well, because it has 2 additional chapters, one on distributed Agile, which is very tough, and one on enterprise Agile, which you should stay away from. So, given that, and I'm writing some new books, doesn't really matter. Well, the right one does, actually. It's about how this culture is changing, so basically this talk is aligned with the second book. I'll tell you a story first, and the story is that in September, I was in Wales. Have you ever been in Wales? It's a beautiful country. And the thing is, I'm a big Led Zeppelin fan, as you might have guessed from my tattoo. And this is, I know this is old music for most of you. I did a talk on Friday in Poland at a conference, and I asked if anybody was born before 1970. I was the only one in the whole room, and there were 500 people in the room, and I was like, I'm getting old. So I'm listening to old music. Now, when I was a young kid, about 13, I think, I bought this album, the album, not the CD, the album, so you can open it up, and there's a turning wheel in it. And there's a song on here, and it's actually number 9. It's called Brunjauer Stomp. And of course, my English at that point in time wasn't as good as it is now, but I didn't understand the title. And it took me a whole while to figure that out. The problem was, when I was 13, there was no internet. That means there was no email, there was no Wikipedia, there was no Google, there was no Google Maps. So I had no way of figuring this out, what it was. Until years later, the internet came, and then I could just look it up on Wikipedia. That changed a lot, right? The fact that we could look things up changed the world big time. And then it got even better. Google Maps came out. I could look it up. When I was 13, I didn't even have a map of Wales, let alone that it was so detailed that it just had this little cottage on there. So last year, when I was in Wales, I thought, you know what, I want to visit that place. And as you can see, again, Google Maps, it is somewhere in the middle of nowhere. I actually had to walk up a really steep hill to get there. But when I got there, you can imagine I was really thrilled, right? This is me standing at that particular place where Led Zeppelin actually recorded a lot of their songs. Now you might think, what does this story have to do with doing software development? Well, quite a lot. It sort of illustrates how the world has changed over the past 30 years. And it changes even faster. The thing is, it changes all the time. And it changes to a scale that is very hard to imagine. As a developer, I've seen technologies come and go, and the rate at which they're coming is increasing. And it is not increasing at a linear speed. It's actually increasing exponential. And you can see that from this graph, right? This is an exponential line, right? You see that, right? This is Moore's law. Moore's law says that the number of transistors in a dense integrated circuit doubles approximately every 2 years. That means every 2 years, the possibilities of the hardware as such doubles. Now, you might think that this is a linear line. It's not, right? It's actually, if you look at the Y scale, it's actually climbing up pretty fast. So we're going faster and faster. And you could, in a larger scale, see that, and it's the same as Dave talked about this morning. It's the speed at which we're picking up new things. If you look at AI, there was a video a couple of weeks ago about a robot jumping on a table and then do a somersault backwards and landing on its feet. And you might think, wow, that's pretty amazing of this robot. Well, it's not. The robot is just a piece of steel, right? It's amazing that there's actually developers who can write code that allow you to do this. We couldn't do that 2 years ago, right? We couldn't do that 5 years ago because there's things that change even harder. And there's some points in time that are very, very important in this change. One of them is actually when the personal computer came out. Did you guys have one of these? Are you too young for this, right? My first computer was a Commodore 64. Does anybody remember him? Oh, good. I still have mine, right? It's like 35 years old, and it still runs. It doesn't do anything, well, because you used to have cassette tapes. Oh, you don't know what a cassette tape is, right? And you used to plug in. They're all broken, but the machine still runs. So this machine came out in 1981. I think 1981. Is it on the slide? No. And it was really, really expensive because this was top-notch technology, right? You used to have 16K onboard RAM. 16K, right? My phone, which is in my back pocket somewhere, has about 128 gig, I think, somewhat. So a lot more. And this machine here costed $3,000. But then it had a single diskette drive. Not 3.5, but 5.25-inch diskettes, right? The floppy ones. You remember those? That is not too long ago. That was 1981, right? And then, some years later, to take a big plunge, Amazon came out with EC2. Now you might think, oh, someone else is hallelujah about the cloud. Well, yes and no. It took me a while to figure out what I could do with it. But the thing of the fact that we could use somebody else's computers, because basically that's what we do, right? We use Amazon's computers. We use Microsoft's computers somewhere in the cloud. We used Oracle, IBM, whatever you do. Most people use Amazon, by the way. They're like 14 times bigger than all of their competitors. Well, we are now using Amazon's computers, Amazon's processors, Amazon's storage capacity, Amazon's memory to do things that we couldn't do before. I work for a company that builds software in the insurance market. One of the slowest processes that is around in the insurance market is renewing all policies every year. Right? If you're an insurance company, you have like 500,000 policies, and they need to be renewed. There's some financial transactions coming out, some PDFs rolling out of that. The previous company I worked for was an insurance company. I was their CTO, and they had software to deal with this. That software ran for a whole weekend, just to renew all policies, every month. That means if the process goes right the first time, it only took the whole weekend. If it didn't go right the first time, they had to stop it and redo it on Monday morning. But that particular process blocked the whole system. which basically meant if it went wrong the first time, they couldn't work for 3 days. Now that's pretty expensive if you're an insurance company, right? And then we rebuilt all this stuff into microservices and into continuous delivery, and we put it out in the cloud, and then the whole process ran in half an hour. Basically because we could use so much of the computing power that we didn't have beforehand. But the cloud changes even more, and I'll try to show you that in a second. See, stuff like this is going to happen. Companies that do things now will do different things in 10 years. Banks will be totally different. Software development companies will be different. Microsoft is now using their cloud to allow people to research cancer, to figure out and to look through the DNAs for faulting strings of DNA, right? And that takes a lot of computing power. Microsoft has that. Amazon has that, so we have it too. So what does that mean? Now, if you look at the financial market, there's a market that I work in a lot, coincidentally, because I have nothing with banks. In the Netherlands, we have a lot of startups, a lot of scale-ups that do stuff in the financial market. Now, in this financial market, that means you used to be, if you're in there, you used to be a bank or an insurance company, right? Banks are really, really big. They have tens of thousands of people working for them. And now, if you look at this landscape, there's around 3,000 startups in the financial market alone in the Netherlands. That means if only one of them is able to build a system that does the same as these big core banking systems that are maintained by thousands of people, and if the small company can actually build the same system, and there's actually companies out there that have done that, they can compete with a large bank with 10 people and no hardware, because the hardware is somewhere in the cloud. And that changes perspective. Also, that also means that other people will be coming into the field. This is, it's in Dutch, I'm sorry about it. This is the CEO of ING Bank. He was just rewarded a 300% raise in salary. And then that was last week, and then they had to cut it down, and he didn't get it, and sad for him, but he earns a lot of money anyway. So he says, basically, ING, big bank, sees the biggest threat in Amazon. They think Amazon, but also Apple and Google will go, maybe even Facebook, they will go into payments as well. Now, those are tough companies to beat, because they not only have the computing power, they also have the people to build stuff. But what you will see is that companies from way other markets will come into your market as well. I'll give you one example of that. An article I read recently said, the best low-cost airline in the world, I had never heard of them, by the way, but is taking on Amazon and international banking. AirAsia is going to do payments. Because in their airplanes, if you buy something, because you don't even get a cup of coffee for free these days in an airplane, and I sit in quite a few of them. I had to pay for a sandwich yesterday, which we used to get that, right? And it has been changed. So now AirAsia, who has to do payments on board anyway, they thought, you know what? We have to do payments anyway. Let's build a banking system. And they are entering the same market. And they can do that because of the fact that we can put stuff out there in the cloud. We have vast amount of computing power, vast amount of storage, almost endlessly. And we can thus build different things. So we need to change. Now, if you come from a classical software development environment, like probably this guy, we have been doing it wrong all the time. We have been building software in the wrong way for a lot of years. And I'll just briefly do a very short metaphor of that. So basically, what we have done in this field, and it's everywhere I go. So every client I go to does this, right? Every time you have some time to build something new, you have to figure out what to do. Are we going to add a new feature to the product, or are we going to refactor it so we can keep the quality of the code up? Now, usually the developers say, oh, we have to do some refactoring. And usually the product owners or project managers or the client or whoever says, no, we have to add new features. So if you do that time and time again and again and again and again, what will happen is that the quality of your code will decrease. Basically because you add all these new features to it and your code base starts being wobbly. Now, in a short metaphor, it's basically like this. Do you know these guys? It's a well-known cartoon series from the Czech Republic. It's called Neighbor and Neighbor in Dutch. I'm not really sure what it's called in the Czech Republic. But they venture into a new project every episode. And they do strange things. Like in the first episode, they are starting to make a fireplace in their house out of wood, which is not a brilliant idea. And along the episodes, what they'll do is they'll add on new stuff to it just to keep it from falling down or adding new features to it. In the end of every episode, the whole thing explodes. That is how software development works, right? Except instead of 3 slides, this happens in a period of 20 years. If you have systems in your company that are like 20 years or older, the quality of that code is for sure decreasing. Probably decreasing a lot. Probably you're already thinking about how can we build this new? And at the same time that you need to do that, you need to still compete with other parties coming into your market. That means you have to get your speed up. I'll skip this one for a second. So, what I see happening in the field, in software development, is this. It is that everything we do, we will start doing that in smaller pieces. That means that the cycles we use will be shorter. Even shorter than Scrum. You might think, oh, we're doing Agile. We already have short cycles, right? Are you all in Agile projects or Agile companies? Wannabe. That's a good. It's a good dream, right? So, so how long are your sprints? Who has 3-week sprints? 4-week? 2-week? So most of you are on 2 weeks, right? Are there people who are having shorter cycles than 2 weeks? So how long? 1 week. Are you going to production at the end of the week or? Depends. If you're in Scrum, right, you have to answer all questions with "it depends." That's all you need to learn about Scrum, right? You only need to say, well, it depends, right? And so we have short cycles as well. I was writing some code in the back in the morning, and I checked in my code, and it's already in production. That's because I just push it into production. Now, there's a very long process that goes up, but it only takes a few minutes. And I'll show you, actually. So I think that we're going to change things a lot. So first of all, I would say that we will stop doing projects in this field. Because doing projects, fixed price, blah, 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 is not the right metaphor for doing software development. If you want to do fixed price projects, go into another industry. Because software development is not good at doing this. And it doesn't mean that we have to get better at it. It means that the whole idea of having these fixed price projects does not fit how software development works. I'll try to explain that. So the next thing is, we will have even shorter cycles. If you have cycles of 2 weeks, think shorter. If you have cycles of 1 week, think shorter. You can have cycles that are just as big as the items you work on. I built a new use case this morning. It's in production right now. It literally is. That's the length of a cycle. Because the shorter the cycle, the easier it is to get feedback. And the faster you have feedback. And the faster you have feedback, the faster you can go forward. Right? So the cycles will be shorter. And I also think that teams will be even smaller. So if you're in a Scrum team, 7 plus or minus 2 or 6 plus or minus 3, whatever you believe, they will be smaller. I think teams will go back to like teams of maybe 2, maybe 3 people. Because that, to me, is the most efficient way of working. And last but not least, we will build smaller components. Delivering whole systems, that will stop. We will not do that. We will not build big new systems anymore because we don't have the time to do that. To build a big system, you need big time. We don't have big time anymore in this industry. We have very small bits of time. That means if you already have a system, you can add small pieces to it. And if you don't already have a system, You build the smallest product that you can think of and start adding features on top of that. That's the way we will work in this industry, I guess. In short, we start mentioning this thing, the continuous culture, because if you start doing this, it will change your organization. It needs to change your organization, because your organization needs to be able to manage this particular speed. And your organization will start traveling at a much higher speed with a lot less hierarchy in the organization. I'm trying to motivate organizations I work with to get rid of management. Not the activities, but the people who have the functions, because doing things in managing things is just a role someone has. And if you do that, your organizations will be much flatter. The responsibilities and the way you make decisions will be much lower in your organization. Meaning you can go faster. Because we need to go faster, basically. So, first of all, you need to figure out what to do. So if you don't have already a system in place that you need to maintain and update and add new features to it, and you start building new, build the smallest thing possible that does the work. It's basically called a minimal viable product. But before I go into minimal viable products, I have to show you another model. This is a very nice model, and I discovered it like, I don't know, 2 years ago, I guess. It's written by a guy called Dave Snowden, who is a professor in Wales, coincidentally in Wales. And it has 4 zones, or actually 5, but I'll leave it to 4. So, and the thing is, we have to start realizing that we have been using the wrong metaphors in this industry for the past 50 years, and it's not much older than that, right? So the picture of Margaret Hamilton that you saw on Dave's slide deck, that was like in 1967. That was the year I was born, right? And the whole industry is only 10 years older than that. So it's a very young industry. Now the thing is, we have been treating this industry as if it was a construction industry. As if we could literally know everything there is to know and be able to plan that. And the thing is, this industry is not like that. So, if you look at Dave's model, it says basically the first zone is called the simple zone. That is where simple problems are solved, right? There's a problem, you know where to go to, you know what to do, you'll solve it, done. That's the easy part. We solved most of these problems like 30, 40 years ago in this field. The second part, the second zone in this model, is much more interesting. It's called the complicated zone. Now, the complicated zone says, if you have a problem, and you put enough analysis on the problem, you find a solution, and you'll be able to build it right away. That means it's plannable, it's predictable, right? We have been treating software development as if it was in this particular zone. If we discuss it long enough, if we do enough analysis on it, if we draw the whole architecture and the whole detail and whatever, we can build it, because then we know everything about it. That model is wrong, and it has always been wrong. Software development has never been in this particular zone, because most of software development, serious software development that is in the third zone. It's called the complex zone. Now the complex zone basically says, well, you could try something out, see what happens, and respond to that. That is basically how software development can best be done, because there's so much change in the technology, there's change in the people, there's change in the teams, there's change in the way we work together, there's change in with who we work together, different cultures, right? And technology is changing so fast, it's very hard to keep up. I tried to illustrate that earlier in the talk. So basically what the model says is, if there is a problem, you might say, I want to go in that general direction, but there's no way you can plan to exactly be there in, say, 3 years' time. The only thing you can do is say, okay, we're going to try this particular solution. If it works, we'll go in the same direction. If it doesn't, we have to adjust. We have to adapt. We're going to find something that sort of puts it in that direction, and maybe then that, and that, and that. And eventually you'll get somewhere, but not exactly at that point, because there's very little chance that you will end up exactly at that particular point. So the only thing we can do in this industry is try something out, see if it works, continue, If it doesn't work, we'll change course. That is the way we should do software development. That also means that the whole idea of having a fixed price project should go out of the window, because it doesn't work. I've never seen it working, by the way, and I've been in this industry for over 30 years. So that also means that stuff like the iron triangle, right, where you try to balance resources, people, time and money, and get some functionality out, gone. It should be gone, right? You shouldn't see this anymore. And I haven't seen it in quite a while. Also, if you want to make a detailed planning up front in your project, stop doing that. Because there's very little chance that the effort that you're going to put in very detailed planning sessions is actually going to make up. Because there will be change in your project. It will happen. Change is everywhere. Basically, it's the only constant that we have. That means you have to start looking at building stuff differently. Instead of saying, I have 100 features that I need to build into full detail before my product is done, you build the first feature. And you build it in a way that your client says, okay, I can work with this. I'll give you an interesting example. A friend of mine who was a project manager at Capgemini, one of my previous employers, he said, oh, I finished my project on time, on budget, and we finished the delivered functionality. He said, so it is a success. I said, what do you mean, so it's a success? Maybe you could have done it for half the money. And he was like, no, we finished on time, on budget, and the right functionality, so it's a success. I said, maybe you could have done it in half the time. Who knows? And he didn't understand. The thing is, if you pick up one item by item from the backlog or whatever you call it, and you say, I'm going to build this one, think about the version of that particular feature you will build. Will it be a very simple version, like a skateboard version, or will I build the full featured set that you can do with this particular feature? Ask your client. If he says, well, let's build the first one, very simple, see what happens. It's done in 2 days. Or you can do the next one. And for the next one, he could say, oh, you know what? Maybe this one, we need to extend it a little bit. We'll build the bicycle version of this one. So in the end, you will have built like 25 bicycles, 40 skateboards, 3 motorcycles, and 2 cars instead of 100 cars. That means that your project or building the product is much more efficient. That also means you can stop creating all these long plans. You have to got a roadmap, a general direction where you want to go, which you can work on and take step by step, and then see where it goes, and then take the next step, build the next feature, again and again and again and again. Now, if you do that, you will have very different things to do. What I do with my teams usually, if the teams I work with, is the first question I teach them to ask continuously is a very simple one. And that is the question, do we need this now? For everything somebody comes up with, usually product owners, clients, whatever you might have, ask them the question, do we need this now? Or is there something else that is more important? And if we don't need this now, don't invest time in it. Just do the things you need to do now. And then you might think, yeah, but the general picture, blah, blah, blah. The general picture also changes. It changes all the time. It's a different perspective. Also, another good thing about this is you can stop estimating. Isn't that good? Wouldn't you just love stop estimating? Are you good at estimating stuff? No, right? None of us is really, actually, because this field is very hard to predict. Now, there's a good thing. So if you have a roadmap full of items you can do, let's say you have 100 items on there, there is this thing called the law of large numbers. Now, the law of large numbers says the result of performing the same experiment a large number of times, this is the second half of the sentence, right? According to the law, the average of the results obtained from a large number of trials should be close to the expected value. That means if you have a scale, let's say from 1 to 5, and you estimate 100 items on that scale, and you take the average, what will it be? I can tell you, it's pretty close to 3, because that's the average on the scale, right? So that means if you have 100 items, instead of going through these estimation sessions, doing planning poker, t-shirt sizing, function point analysis, whatever you do, stop doing that. Just count the work items. If they're all sort of the same size, there is no gain benefit from doing estimates. Counting is enough. That saves an Agile project a load of time. And then it means you can stop doing projects. Because there are no projects anymore. We will build products and add features to them. And even if you don't have the product, you build the minimal viable product first and then add features to it. That's all you need to do. It makes life really simple. Also, it allows you to have even shorter cycles, right? If you look at Scrum, so this is a picture from my last book. This is my own handwriting. This is a very basic cycle, right? It says, oh, you have these 2 or 4 week, whatever you might have, length iterations, and we will estimate some work at the start of the iteration, execute the work, and deliver at the end of the sprint. That's basically the model, right? That means you all have these very small products. And then there's always people say, oh, we need to scale that up. So what does it mean, scaling Agile up? Does that mean that you have multiple scrums, and then you have the scrum of scrums? Have you ever been in such a meeting? I have. It doesn't add value. Or maybe you are doing an Agile transformation, and you're moving into something called SAFe. If you are, and you think you are doing Agile, you're moving in the wrong direction. You're making stuff bigger instead of smaller and faster and shorter, right? If you want to be Agile in a company that does Agile transformations, teach them to go the other way. This is the wrong model. So what else? Do we do the Spotify model? Who of you is doing Spotify? You don't dare to raise your hand, right? So the thing with the Spotify model is, it worked for Spotify. Spotify is a company that grew enormously in a very short period of time. So they needed a structure that could handle that particular growth. There's a large bank in the Netherlands, I'm not going to say which one, but it's very easy to figure out, that is actually copying the whole Spotify model. So they now are hiring like 2,000 chapter leads. Really, it's not a joke, by the way. And tribe, whatever they call, and team leads, and they have 7 layers of managers on top of that, actually. So it doesn't really work. The thing is, they are not Spotify. That means that this particular model works well for Spotify. By the way, people from Spotify said they are stopping to use this model. They're changing it into something different because they have learned and they've figured out something better to do. That doesn't mean that you now have to all start copying the new Spotify model. It means you don't copy Spotify. Because you're not Spotify, you're your own company. You should think for yourself how you do your projects, right? Not somebody else's model is going to do the work. Not Scrum, not Spotify, not the models I use. Use your own ideas. That's basically the point. Unless you are Spotify, of course, in that case you're allowed to copy Spotify. And I'll skip this one for a second. And the thing is, Scrum also doesn't always work. These are burned down charts from a project I visited in Belgium. And they were sort of, the project sort of failed. What happened here is, they did typically Scrum, right? They did everything by the book. They didn't have a project plan because that's not in the Scrum guide. They didn't have acceptance criteria for the software because that was not in the Scrum guide. The client, by the way, was a nuclear reactor. It's very good not to have acceptance criteria for your software, right? And so this is the first sprint. And they estimated the work, and at the end of the sprint, they still had some work left. I'll show you the second burn down. Same thing. They had work left at the end of the sprint. Third one as well, fourth one even too, and the fifth one and the sixth one. And this is the point in time that I got in. And they said, could you help us out? And I said, what are you doing? You're having still a lot of work left. And then the project manager said, yes, yes. And now, instead of having 100 points on average, they estimated, for the remaining 3 sprints, because we have a deadline, they need to do 300 points. And I was like, well, good luck with that. So he hired 200 people from India. And I have nothing against people from India, because they're usually good developers, except adding 200 people to a project, right, doesn't really help, especially if you only have 3 months left. So the project failed miserably, cost a lot of money. Project manager got fired, by the way. And the whole thing is, If you have a backlog, this whole idea of having these 2-week sprints goes out the window. You can stop sprinting. To me, that saves a lot of time, right? All these refinement sessions and whatever you might have, they eat up a lot of time. The company I now work for, they did that one day with the whole team every 2 weeks. Can you see what that costs in money? I would rather have these people write code, and myself as well. So the thing is, the Agile Manifesto says to satisfy the customer through early and continuous delivery of valuable software. That doesn't say you only deliver every 2 weeks or every 4 weeks. That says continuously. Continuously means as often as you can. And that is not every 2 weeks. Because if you automate the living hell out of your project, out of the stuff you're doing, automate all your tests, automate your deployments, etc., 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 you can actually be much and much faster. And you will be. So I'm going through this really fast. The thing is, you have to question yourself. You have to ask yourself, how often do we go into production with stuff? Is that once a year, twice a year, 3 times per year, every 2 weeks? Every day. And the difference is, if you do it every day, your whole process is much more efficient. The smaller the delta is between the last time you went to production, the smaller your problems are. If you wait half a year, the mountain of problems that you have to meet up is much, much bigger. So keep the deltas between going into release as short as possible. You know what the record is of the number of times going into production with code on a day? You don't know, probably. It's 7,478 times per day. It's the record held by Amazon, of course. I think the code in the company I now work for goes into production maybe twice a day, sort of on average. And I want to be much, much faster because we can become much more efficient. And to do that, you need to do continuous delivery as well. Continuous delivery is a technique that helps you speed up. It helps you gain quality control over your code. And how you do it is, you do it with, for instance, setting up pipelines. Has anybody of you seen a pipeline before? Okay, only a few, right? I'll try to explain it briefly, although I will go over time, but this is an interesting concept, right? What you see here, and it's all green, which means it's good, is basically, as a developer, when I check in my code into the central repository, this thing will be triggered. It will build the software, compile it, run all the unit tests that I've written automatically. If that's okay, it goes to some quality assurance tool called Sonar. That checks for a lot of code quality stuff. Then we actually put it into a Docker container. Doesn't really matter if you don't know what it is. We put it into a Docker container somewhere on the internet, and we deploy it to basically to Amazon. Somewhere in an environment in Amazon, I think it's in Frankfurt, this one. And we deploy the code there, run more tests, because that is where we test the deployed software, and then we deploy it, if that's okay, to a second machine, also at Amazon, but I think this one's in Ireland. I don't know why, it's just this, maybe it's cheaper, I think, or whatever. And we run the integration test on that. All is automated. If that is okay, it goes into the acceptance environment, or in this particular case, it goes to an in-between environment where it's tested with all the other pieces of software from the same company, and then it goes into acceptance. The only thing they still have to do is push a button to get it from acceptance to production. Now, this whole process is about 5 minutes long. That is the time we need to go into production with new code in a very controlled way. So this is not cowboy country, right? This is a very controlled way, a very professional way of writing software. It means you have to automate everything. You have to automate your tests, because the more you can automate them, the faster you get your feedback, right? Manual testing goes out of the door. We don't have manual testers anymore in this field in about 5 years. So if you're a tester, learn how to write code. The thing is, most people have very little automated tests, very little unit tests, some integration tests, and a lot of manual testing stuff. And it should be the other way around. It should be that unit tests, which are written by developers at the level of code, should cover most of the code that you have. Because all these integration tests and end-to-end tests and web user tests, etc., are much more expensive. So you don't want to have as much of that as possible. You want to have as little of that as possible. So you should automate all of that. And teams will have to focus on that. So the next thing is, if you're automating anyway, you can also automate away your hardware. Right? You don't have to say, of course, every presentation needs to have a kitten in it, right? This is a very cute way. It's the way we treat our hardware so far, right? It's like, oh, dear machine, you're broken. What shall we do? Shall we put in a new board or a new plug or repair something? And we keep it forever. In the basement, preferably, where it's safe and dark and not too moisty and stuff like that. Well, we don't keep our kittens in the basement, of course, but so far for the metaphor. But the thing is, since we're in the cloud, hardware is not something physical at your place anymore. All of those computers will go out of the door because they will be virtually run somewhere in the cloud, which basically means that I can actually write some code, some script, usually in a language like Groovy or something. It's a really horrible, ugly language. But the only thing it can do, we run a script that says, please set up a computer. Please set it up that it runs Docker containers, that it runs a Mongo database, that it runs Kubernetes, that it runs this and this and this. All this stuff, all these operations people are doing, you also automate that. So that's setting up a new environment, a new machine, and everything that you run your software on is just also a click of the button, because it saves a lot of time. If you give your developers and your operations people the time to do stuff, they will automate everything. Because developers are by nature lazy people, right? I'm a developer, so I can say that. So we are lazy, so we automate stuff. So give the developers the room to do that. And if you do that, you'll end up with this. And saying something like, this is just a tweet by a guy called John Cutler, saying, oh, ideal would be one-day sprints, no stand-ups. I've been doing stand-ups for over 20 years now. I think they're boring. Sorry to say that, but have conversations. Just talk to the people. I talk to the guys in my team the whole day. I have had WhatsApp open for the whole day. I've been in discussions with them the whole day, even though I was here. You can do that too, right? And agree on something to build, something really small, build it, put it out there, and do the same thing again tomorrow. That's the only cycle. That's the only process we need in software development projects. That saves a whole lot of energy, a whole lot of time. And I think this whole industry is going there. That means we'll stop doing project. I have one more topic, and I have only like 3 minutes to do it, so I'll do it briefly. The thing is, I think we will move into even smaller teams. We moved from, let's say, in Scrum it says like 7 plus or minus 2. Hey, there's my girlfriend in the picture, and she's in more pictures, by the way. But anyway, and teams are changing as well. We see these teams that in Scrum they become slightly more self-organizing, and what you see is they become more and more autonomous. If you break down all these levels of having to do with people making decisions that are not their architects and managers and stuff, if you move that all down and all that responsibility into the teams, they will become autonomous. That doesn't mean, by the way, that your office has to look like this, right? This is the Zappos office, and they're always used as an example of how fun this can be. I don't like this. I don't feel comfortable in pictures like this. I'll show you another one. This is, again, my girlfriend in a job interview at a very cool company in the Netherlands. And she's in a meeting room with the CIO, I think, of this company. And the meeting room is filled with little balls up to here. And this is not the IKEA, by the way. This is just the company building software. I think we are overdoing it a bit, right? But the thing is, if you try to move people into being self-organized, that is totally not easy, because it is way out of most people's comfort zone. If I tell teams to say, hey, you know what, I'm going to help you to become more autonomous, more self-organizing, more making your own decisions. And the first thing they'll ask me is say, okay, so what do we need to do? Right? They're not there yet. The problem is, how do you teach people to be self-organizing? That takes a lot of coaching. It's much more than saying, oh, we're going to draw an owl. You draw the 2 circles and then you draw the rest of the owl. Figure it out yourselves. It doesn't really work like that. It takes a long time and a lot of coaching to get people to do this. But it is important, because you see that these teams are much more able to deal with the complexity of software development. They're much faster, much happier too, by the way. And you know what works? Less rules. That's funny, right? This is a crossroads in Amsterdam. At this particular crossroads, there were a lot of stop signs, and you see all this stuff on the street. And as an experiment, what the Amsterdam Council did is they removed everything. They removed all the lights, they removed all the signs, and they removed everything from the street, and they let the traffic figure out itself. And you would be surprised why it works, right? It works because people with less rules have to communicate. Basically, if a BMW 3 Series crosses my road and I'm trying to cross the road, I'll be careful. I'll look the driver into his eyes, and given the fact that it's a BMW 3 Series, I'll let him go first. He'll run me over anyway, right? So the thing is, people start communicating. Once they start communicating, they can collaborate much better. That's the whole secret. So the secret to me is having less rules. Not saying that they have to do this, file a report, etc., 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 right? Give them less rules, because less rules means more efficient teams. And we moved from really traditional teams in software development, having different teams per different roles, to agile teams where they're all multifunctional, right, or multi-cross whatever. And now I think we're going to move to this. Having a pool of people, my current pool, I'm experimenting with that, is like 25 people, and have them figure out themselves what way they want to collaborate. They sometimes collaborate, they pick up an item and they say, oh, could you help me out? These two will work on it, and then they'll split up again, pick up the next item, somebody else, some different ways of working together, and it changes all the time. It's very organic or dynamic or whatever you want to call it. And I call that micro teams. And the thing with these micro teams is they work best if let alone. It helps if there is a technical leader saying, oh, maybe we should solve it like this, but all decisions are in the team. And with who they work together and how they work together, it differs from item of item that they pick from the backlog, but they work together, really cool. Now, I can spend about an hour on this particular topic, which I will not. Bottom line is, you have to allow people in the teams to learn for themselves. Send them to conferences. Send them to training courses. Have them do all sorts of games so they can actually learn about everything there is to know about software development, and about being in teams, and about collaboration, and about making decisions for themselves. And then you can stop doing projects. So, very short retrospective. I have to do retrospectives before we do the retrospective, of course. The thing is, this field has been doing things all wrong for the past 60 years, right? We went into this particular model called Waterfall, thought it would predict the world, thought it would be successful. It wasn't. Waterfall should be made illegal. They should be fined. People should go to jail for practicing Waterfall. It's wrong in this field. It's not wrong in other fields. It's wrong in this field. We are in the complex zone, meaning we have to learn continuously. That is what we need to do. So Waterfall is out, and we have to go differently. We have to think for ourselves. Now, earlier today, and I have to do this, I got a question in mind saying, Ned Stark is a senior product owner. Which approach do you think he will recommend when refining the product backlog? Now, I chose A, because that's the way my teams work. If we want to do some design, we'll do it at the point in time we need it. And that was apparently the wrong question, of the wrong answer, right? I should have said C. Now, the thing is, all 4 answers are good. It depends on who you are and what you do. Because you need to start thinking. You need to keep thinking about what you do. So never stop thinking what works for you. If the Scrum guide says, go jump into the sea, or out of a bridge, you're not going to do that, right? So you have to keep thinking. Don't just copy somebody. Don't just copy me even. I don't have all the answers either. And if you do that, you can figure out for yourself what to do. And that is the best thing you can do, because that makes you autonomous. That makes you a thinking person. That makes you effective in software development, except for having lots of fun, of course, because software development is the best field in the world. There is no better field. So, as a last remark, see, even I went to this farm where Led Zeppelin lived. It's now a micro farm, right? They also do things in very, very small pieces now. So, I'm done. Thank you for having me. Sorry for going like 4 or 5 minutes overtime. 3 minutes 38 exactly. And I hope you have a great afternoon for the rest of the day. Okay.
Thank you. Thank you so much for your amazing presentation. This is for you.
Oh, cool.
Okay, I think we have time for a couple of questions, if there are some. Okay, just a second.
For micro teams,
Wait.
isn't it mandatory to be co-located? How do they collaborate if they are so
Yeah,
small and they have to talk all the time
I
with
would
each
say
other?
it's preferable.
Yeah.
I like teams that are co-located a lot because I can talk directly to the people. It doesn't always happen. The company I work for has 2 different locations. They're like 100 kilometers apart, which means that we have our stand-ups. Yes, we have stand-ups. I don't like them, but the rest of the team does. And the other half of the team is on video. It so happens we have a lot of conference calls during the day. You have to keep your communication clear and open and continuously. It's not always the case that you can be co-located. If you need like 100 developers and there's not 100 developers in where you are, then you need to get them somewhere else, as an example. But preferably, I have co-located teams, yes.
Thank you.
The people within the micro teams.
So how do you organize the people within the micro teams? What do you think? Right, you don't. You don't have to organize anything. There's a list of things that need to be done, right? And every time something's finished, you can pick up the next one. That means the people who, what happens in the stand-ups where I am in my teams is that people say, oh, we're done doing this particular item, let's pick the next one. And then somebody goes that way, somebody goes that way, different teams arise. And that happens again and again and again.
I was referring also if you have 2 or 3 products in the company, not only
We
one
have.
product.
We have 4 products actually.
And
but
how many micro teams do you have in the company?
well, we have 70 people in total, and they're sort of split up per product line, as they call it. But that I wouldn't have that if I was the CEO of that company, which I'm not. I'm the CTO, I would just create one big pool of people, and then sort it out themselves.
Okay,
I would
thank
do
you.
as little as management as possible. Right. So you're asking, what if the team cannot make up their mind, right, about something? Now, what happens is, what I see is we still have product owners. I'm not really sure whether I want product owners on my teams. I would much prefer them to go to the clients and get new items back. But so the product owner is usually responsible for priority still. So what item shall we pick next? We don't order the backlog, by the way. We just say, okay, what's the next item to pick up? Well, maybe this one. Okay, we'll pick it up. It also depends on who becomes available to do stuff, right? Not everybody has the same expertise. And if something technical comes up, there is a technical leader. It's me, actually. So if they cannot make up their minds, I make up my mind and I say, okay, let's do it like this. And the thing is, because you're so short-cycled, if you make the wrong decision, you take a wrong turn, you can adjust it really easily and really fast. And that's the whole thing about software, is that it's so flexible that you can always adjust. That's a big difference between building software and building a house. If I've built the first floor and I say, hey, I want a basement, how are you going to do that? But in software, you can do that, right? You can throw it away and start again. And that is a big difference. So yes, we have a sort of a technical conscience, so to say. That's why I'm the CTO, but and that's good to have. That doesn't mean I make all the decisions. I make as little decisions as I can. It's just sometimes that people. So we now have this discussion today about creating user accounts with a username or an email address. So half of the team want to go left, and the other team want to go right. They couldn't decide. I said, well, let's do it like this, and we start doing it. Maybe it's wrong, but we'll be able to change that next week. Or when I get home on Thursday, right? You have to shout probably, because